Hello, hi. Welcome to the new video. As a series of OWASP Docker top 10, we already covered till day 03. Here we are going to discuss about day 04, that is secure defaults and hardening. We are going to cover what is secure defaults and what exactly the hardening, why secure defaults and hardening does matters, security configuration example, and what is the attack vector in D04, and some real world impact, and how we need to identify a weak defaults with commands, and what is the prevention steps we need to take it, and some key takeaways out of the learning. Yeah, these are the things we are going to discuss in this particular video. So without further ado, let's enter into the video. Basically, whenever we need to make sure we need to build, let me bring up the pen. Basically, what exactly the secure defaults and hardening was. We need to make sure whenever we are starting or building something, we need to start securing it from scratch. Okay, don't consider we can apply that particular patch or update later on. So that is the basic uh, rule it will be followed. And if you see clearly what are secure defaults, so these are the some secure defaults, like most of the points covers. The first one was pre-configured settings that prioritize a security over a convenience. This means secure defaults are a built-in settings, we can say, that protects your system from the starting phase itself. They may not be at the earliest to the work with, but they are very safer. And the second point covers safe by default approach. System start secure, not easy. Let me explain a little bit about this point. Like, instead of leaving the things open and flexible, secure defaults lock the things first, and then you open that particular access or any permissions when you need it only. Okay, so first you need to start securing, and then you need to uh, proceed, or else you need to open uh, that particular communication or whatever it might be, okay, later on whenever it is required. And the next point where it will discuss is about minimal permissions and disable unnecessary features, and restricted access need to be provided. Okay, so containers should obviously run with the should needs to run with a least privileges, and we need to make sure to disable or turn off the features you don't use that, and also block the access that isn't required, and prevent common security mistakes from day one itself. So many attackers, especially the attacks will happen because of weak settings. So secure defaults will reduces the human errors, and it will helps in protecting your containers from the beginner stage, or else from the scratch itself. Okay, if you see here, it is the one of the example, just SSH disabled by default, not running on the port 22. So instead of allowing a remote access by default, SSH is turned off. Basically, this will avoid the exposing your containers to attackers scanning for open ports. So this is just an example how the secure defaults need to be. Okay, so and coming to the second part, which is hardening. What exactly the hardening? And whatever the points we have discussed regarding the secure defaults. Likewise, we will be covering about the hardening also. So hardening is the process of securing a system by reducing the attack surfaces. That means locking down your containers to reduces the, that will reduces the number of ways for an attackers can get into the container. So whenever there is a fewer ways, then obviously that particular system or container, we can consider that is a safer, and less attack surface will be there, right? So that is the significance here. And we need to make sure to remove unnecessary services, features, and access points. Let's say if something isn't required in production, like an extra tool or some packages or some open ports, we need to remove it. Every extra feature is an like potential risk or threat for the system. And the third point discusses about applying additional security configurations beyond defaults. So secure defaults are a good start for that, and but hardening goes further. So secure defaults, whatever the points we have discussed earlier, that will be the beginning, and hardening will be the continuation or advanced further. You can add extra layers of protection, like strict permissions or read-only file systems, and RBAC maintaining, And the next point was following a security benchmarks and best practices. So you need to make sure use your trusted guidelines like CIS Docker benchmarks. Basically, this will tells you what need to be disabled and what need to be restricted and how to configure the containers secure manner. So here is one of the example for hardening. Removing package managers, shell access, and debug tools from production containers. So especially whenever we are working with the production containers, you don't need like all the tools like I mean the default existing tools also like apt, bash, or curl. We need to make sure to remove them by that attackers cannot use them either if they enter into the container. To break out, obviously they need to use some features or tools in the container, right? So by removing these package managers or cell access or some debug tools, so there is a very less chances to break it out. So that is the significance here. And moving further, where we will be covering about why defaults are matter. Okay, so whatever the defaults till now we discussed. So this is the like risk of easy but unsafe. Basically, many like teams chooses quick setups that are very easy to deploy, and I mean along with that they will be uh, carrying a huge security risks also, and that is not a safe manner, right? So these are the some pointers we need to be considered, uh, like which goes beyond security. Teams rush to a production without a secure review. That means security review. Uh, I mean, obviously the teams look for your production releases and they will rush for that, right? So we need to make sure security checks are not skipped, and basically this will leave the containers as a unpatched status. Okay, and obviously they may have a weak settings, and the containers can expose. And the second point was regarding default credentials and open permissions. So some containers come with their default usernames and their associated passwords. If those default uh, credentials are not changed, obviously the attackers can log in to those containers easily. We need to make sure to cross verify and check thoroughly. Unnecessary services exposed to networks. So extra services, whatever we have earlier discussed, along with that, like I mean, services and tools also, services like SSH or some debug tools earlier we have discussed, or in some APIs uh, that might be running and reachable from outside world also. Okay, so this becomes entry point to the attackers, and their job will become easy and easy targets for automated attacks. Obviously, the person who is trying to uh, like attack or who is working on that part, they may use some automated bots to scan for a weak setups or weak containers uh, that may have a default settings. So with, I mean, by having these kind of checks, they can easily identify. So that is the that is why the default or I mean the defaults are very much important and mandatory to verify that. And as per the like one of the study, 80% of the breaches exploit weak defaults and misconfigurations. So most security incidents are happen because of the poor initial setups, and fixing the defaults early can prevent this kind of major exploitation or damage later in the future. That is the significance of this point. And moving to the next slide, where we will be discussing about security configuration examples. So what need to be disabled and what need to be enabled. First, we will cover what need to be disabled. Whenever we are configuring a security into the containers, make sure we need to disable SSH daemon in containers. So what exactly it does was containers uh, don't, I mean, don't need an remote shell access inside them. So we need to use Docker exec if needed whenever we wanted to run a remote shells, and leaving this SSH open is a huge security risk. So that is the reason we need to disable the SSH daemon in containers, and we need to make sure uh, debug and development tools. I mean, make sure to disable these debug and development tools. The tools like curl, wget, vim. So or any compilers that should not be needed or required in your production containers. So better to disable that, and if not, the attackers can use them to download some external malwares or expose your systems to the outside world. And the next point was we need to disable unnecessary network services. we need to make sure to turn off the services that isn't required. Every open port or some background service is a potential entry point for an attackers. So these are the things need to be disabled. And moving further, what need to be enabled for a security configuration as a security configuration? You need to make sure read-only root files permission. This basically prevents the attackers or applications, existing applications, from modifying the system files. So that may contain like crucial important data. Okay, and no root user exception. So run the containers as a non-root users. If someone breaks in, they won't have admin level of access. So that is the significance here. And the next point was resource limits and quotas. Basically, we need to set up a memory or CPU process limits. This prevents the containers from consuming all system resources or going denial of services. Okay, so DOS attacks can be prevented by using, by enabling these resource limits in the container. So this was the one of the example container where it will run a container with a read-only file system with a non-root user and a memory limit also set up. So this is the command docker run -f read only -f user, and this is the user ID, and this is the group ID, and this is the memory limit which was set. So this was the best practice and security configuration example. Okay, and moving further, where we are going to discuss about the attack vectors for D04. Okay, here the first attack vector was exposed to APIs. So APIs like the Docker remote API should never be publicly accessible. Okay, so let's say if left open, attackers can control your containers remotely also. So in that case, no login also required. Okay, so we need to make sure to do not expose the APIs. Okay, so and the second vector was, attack vector was privilege escalation. Because of this, it will happen. Okay, because of this will happen. That is the significance here. Containers which is running as a root user, root user unnecessarily. Basically, running your containers as a root gives your attackers full control. If they break into the container, they can escape the container, and then they can affect the host system also. Okay, so that is the significance here. And moving to the next attack vector, which is backdoors. So with the help of debug tools and SSH access in production, they can achieve this backdoor vector. Okay, so this was the attack vector, and this was the things can be done with the help of this vector. Okay, so leaving the tools, especially the SSH or debugging utilities or compilers in your production containers, is very much risky. So attackers can use them to explore or control your host system. And the next attack vector was information disclosure. So especially detailed errors messages or some logs can leak the sensitive information of the system, uh, and also it will shows the path of the file system and tokens or some internal APIs that attackers can use to plan the attacks. Okay, uh, information disclosure that contains verbose errors messages and logs. Okay, verbose was the argument for debugging purpose they use. Okay, and here is the real attack where Docker API on port 2376 is exposed. So with the help of this, the full host will be compromised. And this is the one of the real world breach. The attackers can found a Docker APIs which is exposed on the port 2376 with no authentication. They gained a full control of the host machine. Okay. So moving further, where we will be discussing about real world impact of the D07, D03. Here are some of the examples. Let's go one by one. Okay. So the first example was, one moment. Yeah. Tesla 2018, where it exposed a Kubernetes dashboard that led to a cryptocurrency mining. What exactly it happens was in 2018, Tesla's AWS cloud infrastructure was compromised due to unsecured Kubernetes dashboard. So attackers gained access without authentication and deployed a cryptocurrency mining malware, also known as a crypto zacking. Okay. So this confused Tesla's cloud resources lot. This consumed a lot of cloud resources, which is using by the Tesla, and it exposed to some sensitive internal data. So this breach was discovered by a red log researchers who found that the dashboards was publicly accessible, and there is a leaked basic security controls also. Okay, so that was the one of the real world impact which has happened. And the second one was Docker Hub breach. So default credentials on admin account. So what happened was, I mean, we obviously know the Docker Hub, which is a popular container registry provider. So it has also suffered with a breach where the attackers exploit a default or weak credentials on a admin account. Basically, this will allow a unauthorized access to a user's data, and they can potentially, uh, especially the private container registries. I mean, this particular breach was highlighted the danger of the relying on default settings and not enforcing a strong password mechanism. So that was the real world impact which was observed. And coming to the third example, which is the financial service, uh, $2 million loss from misconfigured containers. One of the major financial institutions reportedly losses over $2 million due to containers that were misconfigured. So running with excessive privileges, the misconfigurations was running the containers with the excessive privileges and exposure to ports, and there is no proper segmentation. So attackers exploited these flaws, and they got a lateral access, and they got a access to the sensitive financial information. So this particular breach led to a regulatory security and operational disruption also occurred. And this was the two kind of key points from the statistical data. Average breach detection was 179 days. So according to the one of the industry report, it takes an average of 197 days to detect a breach that's more than around 6 months, uh, where attackers can explore, steal, and damage the entire system. So this was the one of the significance where weak defaults and poor misconfigurations make uh, these things worse also, like more than 6 months also it may take if our defaults and defaults are not properly set. And the second observation was average cost of like data breach was around $4.45 million. So this was the average cost of the data breach, which is happening globally, which is estimated as $4.45 million. This includes financial, legal issue, financial fees, legal fees, recovery costs, and a lot of uh, business reputation losses also. So for companies using containers, insecure defaults and lack of hardening are major contributors to this particular losses, which is showing on the screen. Okay. And moving further, where we will be discussing about how to identify a weak defaults. So one was benchmarks. We need to use a trusted security standards, especially like CIS Docker Benchmark and NIST guidelines. This provides a detailed checklist for what secure defaults should look like and what we need to avoid. And also we need to make sure to use the tools like Docker Breach Security. This was the one of the tool where it will checks the uh, for your host and containers against the CIS benchmarking standards. And Trivy, basically it will scans for vulnerabilities in the Docker images and checks for the configurations and S-bombs also. Clair scanner, it will analyzes the container and uh, the layers inside your container for known CVE vulnerabilities. So that is the thing. And with the help of audits also, we can identify a weak defaults and basically this will achieved with the help of regular security assessments and penetration testings. So we need to make sure to schedule your audits to review your containers and their associated configurations. And also PT, that is penetration testing, will help to simulate a real world attacks and find the what are the weak spots before the attackers can exploit that or reach that. And the next point was monitoring. With the help of monitoring, we can know the anomalies will be detected in the early time. Okay, so like what is the CPU or memory usage or some uh, network communication, how it was happening, and what exactly the behavior of the container. So with this information, we can identify a is there anything going wrong inside our system, all those things. And here there is one of the command where this will runs a Docker bench security that full, with a proper full host system access to audit your system against a CIS benchmarking standards. This was the Docker command: Docker run -rm -it -net host -pid host and users host cap add and audit count. And this was the command we need to make sure to use if you are starting with the hardening. Then that was the starting point. We need to make sure to use the implementation. Okay. And here we are going to discuss about what are the some prevention steps we need to make sure to take for this. So we need to make sure there are some configuration preventions. Also, the process preventions need to be taken. Here, the configuration preventions was we need to make sure to use a minimal base images like Alpine, distroless, where it has only code and associated dependencies, no other than that. And we need to make sure to use a run as a non-root user that will avoid running a containers as a root. And we need to make sure to use a dedicated user with limited privileges to prevent the privilege escalations if the system was compromised. And we need to set up a resource limits, what is the limit of memory that particular container can use, and CPU as well as process to prevent some abuse or denial of service attacks. And coming to the process wise, what prevention steps we need to take for this security faults and hardening, we need to make sure to follow security first Dockerfile templates. So we need to design Dockerfile in such a way security should be first place in our mind, and there is no unnecessary tools or no root access, and proper clear security permissions to the users will be given. Okay. And the second point was where automated security scanning in CI/CD. So integrating the tools like Trivy or Snake into your existing CI/CD pipelines. Basically, this will scans the images and associated configurations, and any found vulnerabilities will be highlighted before they are deploying into a runtime like production environments. And we need to make sure to regularly check the benchmark compliance. So we need to use the tools like Docker bench security to ensure your setup is aligning as per the benchmark standards like CIS benchmarks, and some other best practices are following. So this was the one of the example of the Docker file which is following a best practice. So here they are using a base image as a Alpine and getting a latest image. And here as a run command, they are creating a user as well as a group, and they are adding that user into that particular group. So add group -g, that means a group ID they are keep passing, and this is the app group name. And if this particular condition satisfies, then this particular creating a user and adding user to that particular group is going to be happen. So add user -d, which is by default setting. It will set up this particular user with the default settings, and -u -g, -u1000, which is a user ID. If the user ID is 0, then that is a root user. If the user ID which is greater than 0, then that is a non-root user. And assigning this particular user to this particular group with the -g argument and group name. Okay, and this is the app user, this is the username, and we are shifting to this particular user. Whatever the commands we are running below this, all will run with the help of app user which was created. Okay, and there is no kind of root privileges to that particular user. It is a local user. Okay, and where we are going to discuss about some key takeaways of this whatever we have till now seen. So we need to make sure we need to start securing. So configure security from day one and not as a afterthought. That means the security should be baked into your container step by step from the beginning itself, not in later or any stages. So starting security in the early stages, that will avoid the cost of fix and breaches down the line in future. Okay, and follow some standards like CIS benchmarks and security frameworks, or there are NIST and OWASP like standards also to shape your container security strategy. Basically, these frameworks will help you to avoid common mistakes which is happening among the industry wise, and you need to make sure to automate the checks. So by using the tools like Trivy, Snake, or Docker Bridge Security, sorry, Docker Bench Security, that should be a part into your automated scanning pipeline mechanism, so they can catch misconfigurations or vulnerabilities from your container whenever they go live. Before that will be catched. Okay, and Team training. We need to make sure to understand why the secure defaults will matter. So training obviously helps to prevent the misconfigurations, and that will build a security first culture among the team. So make sure to educate your developers on secure defaults. And the next point was monitor and audit. As already we have discussed, we need to make sure a regular assessment and continuous improvement for like need to be maintained. So we need to monitor what is the container behavior, and like configuration audits need to be done, and we need to make sure to update the policies regularly, and we need to make sure up to date with the threats and vulnerabilities or patches which was releasing in the as the latest releases. So yeah, these are the points which we wanted to cover in this particular video. And also one more last point: security is everyone's responsibility. So don't think like it might be a developer responsibility. It might be a operations responsibility. So starting from planning till the deployment, everyone's responsibility, the security. Okay, so coordinate and implement the security best practices, and have a great learning. And thank you once again for watching the video. Stay tuned for more videos. Thank you.